Mr. Phillips is at the Chick-fil-A during first period, decided not to join us. Or wherever he was at. I don't know that he was at Chick-fil-A. I just know he was not here. Huh? Confirmed. Mr. Phillips was at Chick-fil-A. I hope he watches this. I doubt he will, but since I better have this here. So, adding and subtracting, just like with multiplying, we got to know how to do it with numbers, or we're not going to be able to do it with when we throw variables in there. So, I'm going to go back. No. All right, so I'm going to go back super basic on this. And I'm not even going to, the first one, I'm not even going to do it with, like, numbers. I am going to do it with pizzas. So that first one is 1/4. So that means that our pizza is cut into how many slices? 4 slices. Because our denominator tells us how many pieces we have. And we shade 1 piece. Alright? And then we've got to add our second pizza. How many pieces is our second pizza cut into? 8. So we've got 8 slices in this pizza. Okay? And how many pieces of pizza do I shade in on that one? 3. So 1, 2, 3. Okay, what's my answer going to be?
3, no. Wait, was that right?
All right, so just think about how many, this piece right here, if it was on this pizza, how many pieces would it be?
2.
It'd be 2 pieces, right? Because in order to really like add these together, each pizza has to have the same number of slices, right? So if I take this pizza and I cut each slice in half, now I've got 8 pieces. So what I'm really doing is I'm adding 2 8s plus 3 8s. So if I have 2 slices and I have 3 slices, nope, it is 5 8s. Not 7/4. So, in order to add or subtract, you have to have common denominators. That means your pizza has to be split in the same number of pieces, right? So, like, mathematically, because we don't want to have to be drawing pizzas on our paper for every problem that we do, here, mathematically what you're doing is I need there to be 8 slices in that first pizza, so I had to multiply the bottom by 2. And if I do that, I have to also multiply the top of that fraction by 2. And that is a legal move, because what is 2 divided by 2? Yeah, you can do lots of illegal math moves. Yeah, there are a lot of things that kill some math fairies. But this would not kill a math fairy, because it is legal, because what is 2 divided by 2? 1. So when I multiply the top by 2 and the bottom by 2, I'm really multiplying by 2 divided by 2. And 2 divided by 2 is just 1. And multiplying something by 1 does not change its value, right? So then when I add, you have to be really careful here as well. I add the numerators together, but do I change the denominator? No. That's why I had to get common denominators in the first place, right? I needed my pizzas to have the same number of slices. So this just tells you the size of the slice, and it does not change for that. So the denominator does not get added together on that. So we'll get 5 8s there. So when you're adding or subtracting, you get common denominators first, then you add or subtract the numerator, but keep the denominator the same. Okay? It's a little more difficult than multiplying and dividing, because you got to have those common denominators. So if I look at example 2, do I have common denominators? I do not. Both of them are going to have to get multiplied here because there's nothing I can multiply 5 by that'll give me 3, at least not a whole number, and I definitely don't want to get into decimals, right? And 3 times something's not going to give me 5. So I'm going to have to go with a common denominator where both of these have to get multiplied. What should I use? 3 times 5, which will give me 15, right? So to do that, I would multiply this first fraction by 3 on the top and the bottom. That would give me 12 over 15. And then the second fraction, what do I need to multiply it by? 5 on the top and the bottom. So I've got 10 over 15. And 12 minus 10 is 2. And the bottom stays the same, 15. Yes, but it'd be harder to draw for that because you would have to have you've got 5 slices on the first one, and so when you multiply that denominator by 3, it's like you got to take every slice and split it into 3 equal pieces. So it'd be hard to draw, but it would work the same. Okay, so we are sticking with this method, but we are throwing some X's in there. So what I usually find is kids can't do this right here. They've forgotten how to do it or possibly never learned it very well because sometimes they teach things to you maybe a little earlier than some students are ready for. But they teach this to 5th, 6th graders. So you can definitely learn it. And I think that probably if we went back and took a test on this, you guys could do it now. So let's look at some with variables thrown in there. Okay. Now, the first one is not that bad because we already have common denominators for the first one. So that is very good. We don't have to multiply by anything here. We already have the same denominator. So that just means I need to subtract the numerators. You must, however, be a little bit careful here. You are going to do u minus 6v minus, put some parentheses here, u minus v. And then the denominators are both 24v squared, so it just stays 24v squared. Now the reason we have to have those parentheses is because where I'm subtracting, it's like I've got a -1 here, and that negative gets distributed to both of these. We're subtracting both of those, and if you don't do that, you won't get it right because this is going to be u minus 6v minus u plus v because that negative right there changes that sign. And if we forget those parentheses, you'll probably mess that up. Well, we want to combine our like terms, which is where we're doing that subtraction. So I'm going to put ones in front of all of my variables that don't have a number in front of them. So if I have a positive 1u and a negative 1u, what's going to happen with those? They cancel out, right? So they're just 0. They just go away. And then I have negative 6v plus 1v. What's that going to give me? Negative 5. There will be a v with it, yes. Because we're not dividing it off there. We're just adding them together. And then we got 24v squared. Except that v is eventually going to go away.
Because you're about to cancel it out to make it to where it's just 24 squared or 24v.
Yep, I'm going to cancel out this v with one of the v's in the bottom. The 5 and 25 won't reduce. If it would, we would reduce it, but it will not. So we will get negative 5 over 24v. So, let's look at the second one. It's going to be a little harder because the denominators don't match. So when you have this happen like this, you want to treat the numbers and the letters separately. You're going to deal with them at different times. So let's just think about 3 and 6 first. What is the common denominator we would want to use for 3 and 6? You could use 6, right? And so we already have 6 over here on the right side. For the first fraction, we would just need to multiply by 2. And if I multiply by 2 on the bottom, I have to multiply by 2 on the top. Make sure you put a set of parentheses around that x minus 4y because you have to multiply the whole top by 2. So that gives you over here the 6 that you need. But I have a y squared right here. And over here, this y is not squared. So what do I need to do there? I cannot square it because that is a legal math move that will kill a math fairy. Because if I just think about doing that, like if I square the top and bottom of a fraction, right? If I square the top, I'll get 1. If I square the bottom, I will get 4. Is that still equal? Is 1/2 equal to 1/4? It is not. That is not still equal.
When I say no and you give a pause and look at it,
You are correct. Those two are not equal to each other. We can, square root would be similar. Like if we square root over here, square root top and bottom, like if I have 1/4 and I square root the top and square root the bottom, square root of 1 is 1, square root of 4 is 2. That's not the same. And we can't do anything that's going to change the value of the fraction. So what we're going to have to do, if you are missing variables, you cannot like square things or raise them to the 3rd power, 4th power, 5th power. You can't do that. What you can do is you can multiply by the number of x's or y's that you're missing. So to get y squared, I could multiply by y, right? Y times y would give me y squared. And I can do that as long as I also multiply the numerator by y. And that is a legal move because if I have 1/2 and I decide I want to multiply the top by 3 and the bottom by 3, then that is 3/6, and that is still equal to 1/2, right? So that's kind of equivalent to what we're doing here. So you can't square top and bottom, but you can multiply by the number of missing y's that you're missing. So let's simplify what we've got here a little bit. We've got 2 times x minus 4y over, this is 6y squared. And then we've got 5xy over 6y squared. And so this is good. We've got the same denominator now. So we just need to add the numerators together. You're probably going to see them distribute this 2 right here. So that's going to be 2x minus 8y. And then we've got plus 5xy over 6y squared. Is there anything that I could combine up here? Do I have any terms that are just y's? I do not. 2x cannot be put with 8y, and that can't be put with 5xy because none of the variable parts match. So this is just the answer. It's kind of ugly, but it's the answer. So that gets us started in the right direction. It's about time to go, so we're going to go ahead and pack up. We will finish these at the beginning of class tomorrow and then do a lot more practice with it.
I somehow get less confused by the multiplication and division part than
Yeah.
it's really weird because I suck at both division.
When it comes to fractions, though, the addition and subtraction is harder. I agree.